the other grape she's gonna get to, but you weren't paying attention.
You want it?
And he,
It does taste like ass compared to caribou.
can I ask people?
Huh?
Okay.
No.
Gummy bear ass.
This guy is university.
Oh, and then you got bears and butterflies. Two.
I won't tell you who.
I don't want any more.
So when we resume, I'm going to ask you if there are anybody you want to see on the front board, so you don't say all of them, please. And so that would be the first thing you do, if any. So if anybody wants to, we can put the boards back one more time. Thanks, Jordan, it's always you.
It's like messing,
Oh, put the
it's
boards
like messing up the brakes.
Don't break a break. No, that's all. Just right.
Never set the brakes and then we'll never have to take them off.
Whose bag is this bag?
Yeah, some guys. Some people, man. Right, Emilio?
Right.
Watch out, Jordan. Yeah. Cold.
So much fun.
Bring your orange balls.
Get real close.
You play drums, Sherman? You drum? Okay. You look like you might be.
I'm trying to learn.
Huh?
I'm trying to learn. That's really like, I don't think it's really like a real shop that teach you instruments and stuff. That'd be cool.
You live in the dorm? Your neighbor's gonna like you.
I just go buy a drum set.
You like it, man.
Recommend an electric one with
Yeah.
some headphones, but.
I don't usually go there in my dorm and like nobody says anything because I live like all day in the hallway. And we have 2 rooms, so like my next door neighbor is me. It was perfect.
You work days for the.
No, my next door
Okay,
neighbor
30
is me.
seconds,
Oh,
restart.
yeah.
Like, my room, next room is
I forgot you guys had like double rooms or whatever.
Mhm.
That's nice.
Okay, does anyone have one from 3.2 for the front board? Yes, ma'am? Number which one? 5. Snap problem. You're in time, that's really. So I got number 5. First thing to do, of course, is to read the problem. A stamp collector bought 160 stamps. Wait, now you missed the last class, right? Okay, well, I did an example then, so I'll do one privately for you, because, did you watch the video for the class you missed?
No, it wasn't recorded.
Yeah, I just put it out today, it was my bad. So so we'll work on this individually unless there's another request for 5. Okay, any other requests? Okay, we'll go to the next level of difficulty. Now, I'm going to,
Say some. Can you go over, number,
you're making this up.
7. There's only 7.
That's 5 or 7. The average salary for a college instructor in 1925 was $2,300, and that average salary increased each year by 180. In what year was the average salary for a college instructor? 10,040. So I'm going to let X equal years since 1925. And maybe it'll be clearer. Okay. So X equals the year of 10,040. Okay. So, I'm going to write some logic down. So what we have is the salary in the year 25. I should remember it because that was such a good year for me. Salary in the year of the year plus increases since then. Equals salary now. So do we agree to this logic? Okay. Now X is the year that we reached 10,400. Now what was the salary in the year 1929? $2,300. Now, if we go forward 1 year, then how much gets added to that? If we just go forward 1 year? 180. If we go forward 2 years, how much gets added to that?
260.
So the amount that gets added to it is 180 times the number of years, agreed? Now, the number of years that we're interested in is the number of years that's going to produce a new total of 10,040. So since X is the year in which we arrived at,
10,400.
Oh, yeah, you wrote it down initially.
I'm going to enjoy the moment, it's so rare. I won.
She lost.
Okay, now, what I'm interested in is the number of years that elapse between this salary and this salary. How many years elapse between this salary and that salary? For example, suppose that this salary turned out to be arrived at in the year 1930. Then how many years elapsed? 5, agreed? Suppose it turned out to be in 1935, then how many years elapsed?
10.
Because what we did is we took 1935 and subtracted our starting point. Now our end point is arbitrary. We don't know where it is, and the number of years that elapsed is X minus 1925, the year that we started. So that's our equation. 2,300 plus 180 times X minus 1925 equals 10,040. Now I'm not going to insult you by working out the equation in front of you. I know that everyone's adept at working out the equation, so I'll just pass it back to you. It's no longer a word problem, we have generated our equation. Good question to have asked for you. Good. Had to untangle the words. Okay, now I'm going to go to the next level of difficulty in today's topic. And I'm going to write a FOIL problem on the board. And I'll write this one. 2x plus 1 times x plus 3. Now, in our solution, the trinomial, the first term is going to be the first times the first, agreed? The next term is going to be the two outside terms. Next term is going to be the two inside terms. And then we have the last term, which is the product of the last ones. So 3 is going to help to produce the last term, true? And 2 is going to help to produce the first term. But the outside term is produced by one of the partners for the first term matched with one of the partners for the last term, agreed? This is one of the partners for the first term, isn't it? This is one of the partners for the last term. And to get the outside term, we have to multiply. One partner from the first term and one partner from the last term. To get the inside term, we have to multiply. This term will produce the last, is it not? It's the last term. This term will produce the first, won't it? So to get the inside term, we take one item that's going to be producing the last, and one item is going to be producing the first. So with this understanding that we're going to mix and match partners that produce the first with partners that produce the last to get the inside terms, I am going to factor the following problem. X squared, 2x squared plus 7x plus 3. Okay, first, sign analysis is still in effect. What are the two signs going to be?
Positive.
They're both going to be positive. We've understood that. And that means that the middle term is going to be created by the operation of addition or subtraction. By addition. So we've established that as well. Now, unfortunately, we've got double trouble. Certainly, we need to produce the 3, so we can make a list for the 3. It's a short list. 1 times 3, 2 isn't work, and 3 is on the list, so it's done. But where did the 2 come from? It came from this times this, agreed? So we need another list for where the 2 came from. What are some possibilities of producing the 2? Is a 1 times a 2. Now is where it gets new, because to produce the outside term, we have to take one of these and multiply it by one of these, agreed? Because the outside term is this times that. And one of these is going to go there, and one of these is going to go there. So the outside term is going to be generated by one of these times one of those. The inside term is going to be generated by the other one. When we get the outside and the inside term, we're going to add them together. So let's do it mentally. Try all possible matchings. First, we need to end up with a 7. So, a 1 times a 3 is a what? A 3. Now, a 1 times a 2 is a 2. When we add those together, we get 5, not a 7. So let's match them the other way. A 1 times a 1 is a 1. And a 2 times a 3 is a 6. And when we add those together, we get 7. So we've decided that we have to have a 2 and a 1 here. And we have to match this 2 with this 3. So now tell me, is this 3 going to go on the left or going to go on the right? Where's this 3 going to go? Here or there? Because it has to multiply the 2. Which location multiplies the 2?
Left.
That's right, the right one. Because this produces the outside term, doesn't it? That means that the 1 goes here, and we can FOIL this out. And what we're going to get is a 2x squared, and the outside terms, the 2 times the 3 plus 6x, the inside terms 1x, and the last term's 3, and we get a 2x squared plus 7x plus 3, which is where we're starting. So I'll do one more. And the one that I'm going to do now is 2x squared minus 17x plus 30. Okay, Alex, you're really good at sign analysis. What's the sign's gonna be?
Negative.
Both negative, agreed? This plus sign tells you they're the same. This minus sign tells you what the same is. Now, let's make a list for the 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and 6 is on the list is complete. Let's make a list for the 2. 1 times 2, 2 is on the list. Now, we have to mix and match. One partner here with one partner there, added to the product of the other partners to produce a 17 by addition. Let's start trying. 1 times 1 is a 1, 2 times a 30 is a 60. Add them together, you get a 61, not a 17. Let's match them the other way. A 2 times a 1 is a 2, a 1 times a 30 is a 30, add them together and get a 32, not a 17. The next one, a 1 times a 2 is a 2, a 2 times a 15 is a 30, add them together, get a 32. Let's match them the other way. A 1 times a 15 is a 15, a 2 times a 2 is a 4, add them together, you get a 19. Next one. A 1 times a 3 is a 3, a 2 times a 10 is a 20. Add them together, you get a 23, not a 17. Let's go the other way. A 1 times a 10 is a 10, a 2 times a 3 is a 6. Add them together, you get a 16, not a 17. The last one. A 1 times a 5 is a 5, a 2 times a 6 is a 12, and you add them together and you get a 17. So we said a 1 times a 5 and a 2 times a 6. So we put the 1x here and the 2x there. We promised that the 1 would multiply the 5. So where do I put the 5? On the left or the right? On the right, because it gets picked up as an outside, 1 times 5. And that means the 6 has to go on the inside. Now, so let's FOIL it out. 2x squared minus 5x minus 12x plus 30. 2x squared minus 17x plus 30. Okay, I'll try one more. 6x squared minus 11x. Let's get a really decent one. This is good. 6x squared minus 11x plus 4. Okay, Mercedes, do some sign analysis. What are the signs going to be? Both negative. And that means that we're going to take the outside and the inside and combine them with the operation of addition or subtraction. Addition. Nice. So now let's make our list. 1 times 4, 2 times 2, 3 doesn't work, and 2 is on the list. The list for the 6. 1 times 6, 2 times 3, 3 is on the list. Now let's max and mix with the process of addition, looking for an 11. A 1 times a 1 is a 1. 4 times a 6 is a 24. 24 plus 1 is 25. Try it the other way. A 1 times a 4 is a 4. A 1 times a 6 is a 6. 6 plus 4 is a 10, not an 11. Let's try down here. A 1 times a 2 is a 2. A 2 times a 6 is a 12. 2 and 12 is a 14. Switch them around. A 1 times a 2 is a 2. 2 times 6 is 12. Another 14 did not work. So this produced no gold. Let's try 2 times 3 with all possible endings. 2 times a 2 is a 2. 3 times a 4 is a 12. Net 14. Try it the other way. 2 times a 4 is an 8, and a 1 times a 3 is a 3, and an 8 and a 3 are 11. Gold. So we're going to have the 2 and the 3. And we promised ourselves that the 2 would multiply the 4. So where do I put the 4? On the left or the right? On the right. And now we FOIL it out. 6x squared minus 8x minus 3x plus 4, 6x squared minus 11x plus 4. Okay, now the technique I've been using up here on the front of the room is called mental gymnastics. As most of you have already decided, and in fact some of you probably decided on a different description. But for whatever reason, it is one way of doing it and not actually the only way. So can you, in your text, please go to page 152. Page 152. This is a different technique shown to you by the author. So Emilio, have you got page 152? Getting there. What he's doing on page 152 is he's writing down all possible pairs of binomials that will yield the correct first term and last term. All possible pairs. And then he is foiling each one out, looking for the answer. Now, what he's doing here is exactly the same thing that we did verbally. Only we did it verbally, he's doing it by writing it down. You have to try all combinations by mixing and matching. He writes it on the paper, we did it verbally. If you don't like doing it verbally, then you can write them all down and FOIL them all out till you get the answer. Now, in real life, nobody does either one. In real life, people sort of massage it, push it a little this way, pull it a little bit this way, go with your hunch, do what feels good, and try this and try that, and sort of trial and error. That is what people do in the privacy of their own house, and they don't really do these methodical approaches. So now you can choose your own method of solving these factorings. You can either do these mental gymnastics with these two lists, or you can write down all possible binomials as the author does, or you can do some combination and in between. Try this and try that and go with a hunch. So now whatever method you choose for yourself, I'd like you to now do problem 27. 3x squared minus 24 on the worksheet. 3x squared minus 25x minus 28. Now you don't need me to say if it's right or wrong. Once you have your candidate answer, just FOIL it out. See if you get the original problem back. Jordan, you seem bemused. Do you have a candidate answer?
I do not.
Aye. Sometimes when playing around doesn't work, you just have to go back to a systematic approach. Make a complete list, try all possible pairs. Alex, your answer please.
3x minus 28, and then 1x plus 1.
Usually we say 3x minus 28 and x plus 1. We have a winner, 3x minus 28 and x plus 1. Does anyone want to see Alex do a couple of steps? Yeah, there's a request here, plenty of requests. So please try to explain as much as you can, even though you're permitted to use your own personal method so that people can follow along. A great beginning. That's the way to start.
No, we're going to be opposite because it's a minus there. List. And we do a bit of the 3 times 1.
You're right.
You want to get the 25 in the end, so if you do the 28 as a negative, you subtract 15 and you get 25.
Yeah, that's the way people do them in real life.
So the bigger one's going to be the negative.
And then he plots it out as he did in the seat, and he produces gold. Okay, nice job. Let's everyone please go to number 31. 4x squared plus 16x plus 15. Well, why don't I give you the legitimate problem? Reboot 16x plus 15. Bingo, it's not correct. Amelia, your answer is please.
2x plus 3 and 2x plus 5.
And you thought of it out, so you know you're right, Curtis. Concur, any support? It's correct. Would anyone like to see Emilio show off? Any requests? Anybody want to see Emilio put some steps down? Okay, give people another minute, see if they get to the same place. 2x plus 3, 2x plus 5. People are getting good. So the last one from the worksheet will be 32. 8x squared plus 33x plus 4. have this answer? Do you have?
8x2 square, 8 plus 1,
Right,
x plus 4.
bingo, 8x plus 1 and x plus 4. Would anyone like to see Maroko put down some steps? No request. Okay, now I'll show you another kind of factoring, such as 6x plus 8y. Now remember, factoring is when you break it into two things that you multiply together to get this. And what we want to ask now, is there any common factor between the first term and the second term? 2. So what we can do is take out a 2 to the outside. If we take a 2 out of 6x, what's left? 3x, agreed? Because 2 times 3 will give you back to 6. If we take a 2 out of an 8, what's left? 4y, okay? So you see, this is called factoring out a common factor. So the first thing you do in any factoring problem is you factor out common factors, because it makes anything else you have to do easier. So let's try this one. 9x squared y plus 12xy squared. I'm looking for common factors. Now, you don't have to take them all out at once. You can take them out one at a time. So let's just try one at a time. Is there any common factor, and one common factor we can take out? A 3. And we get a 3x squared y plus 4xy squared. Is there another common factor we can take out? X. So we take an x, and we get a 3xy plus 4y squared. Is there any other factor we can take out common?
1.
Hmm?
1.
What is it?
Why?
Because I asked you, that's why.
Oh.
I have to put up with. Hi. Okay, let's take this one out. So 3xy, gonna leave 3x plus 4y. So is there any remaining common factor? No. So we pulled out all the common factors. Now, sometimes, so let's just have you do one of pulling out the common factors. Let's go to page 158 and look at number 2, 158-2. 50x squared, x cubed plus 30x squared minus 70x. Plus 30x squared minus 70x. How'd I do?
Should be 3x.
Yeah, not so good, eh? How am I doing now? Okay, good. Now, are we done? Maybe yes, maybe no, because trinomials have a way of being factored into two binomials, true? Sometimes they're prime. So let's make our list for 7 is 1 times 7. Let's make our list for 5 is 1 times 5. Now, Alex can tell us by sign analysis that we're going to do the operation of subtraction. So now in mixing and matching, we have a 1 times a 1 and a 5 times a 7 is 35. 35 minus 1 is 34, not 3. Go the other way. A 1 times a 7 is a 7, a 1 times a 5 is a 5. Subtraction yields a 2, not a 3. It's prime. So we're done. Now, let's have you do number 53. 53, page 160. 5x cubed plus 20x squared plus 15. So first obligation is always to pull out common factors. So this is page 160, number 53. Janelle, do you have an answer?
I got 5x and then binomial is x plus 1 and x plus 3.
X plus what?
X plus 1 and x plus 3.
We have a winner. Does anyone want to see Chanel do a couple of steps? We have one request. Chanel?
Okay, so from the get-go, I figured everyone would pull out a 5 and an x. So 5x should be x squared plus, yeah, 4x plus,
No. Oh,
is that right? Yeah.
What a look I
It's
just
supposed
got.
to be there.
My God.
It's supposed to be it. Alright, and then I figured that you could do that because you could. Alright, 1 and 3, there's no number, so it'd be positive. X plus 1, x plus 3. Just bring that down.
and which can be confirmed by falling it out and distributing back into 5x and arriving back at the original. Okay? So now we understand everything that we need to understand about factoring. So the ball is back to you, more whiteboards. Let's go to 5.3. 3.3. Okay, 2, 4, 6, 8, 9. And we have 9 people. This might work out well. Section 3.3. 2, 5, 8, 11, 12, 14, 17, 19, 21. Thanks, guys. Gotta leave about 2 feet there for bodies to slip through between them here. Yeah, there we go. Stop stalling, Jeremiah.
Supposed to be 86, 70, this pink, but I cost them 35.
Jesus Christ. What was it?
It was 56, 70, this one, divided by 35. GDP. Divided by 1.62 equals 1 GDP.
Okay, these went really easily.
Hell yeah.
Or should it be easy? These went really easy. Okay. So when finished, we can push them back and I'll do the last scene act of presentation. Momoko still wants to see that board.
You need over here too?
Yeah. Hey. Okay, I'm gonna write an equation on the board and ask you to solve it. 2x plus 2 is equal to 14. And what value do you get for x? 6, x equals 6. Are there any other answers? No, there's only one answer. There's only one number that will solve this equation. I know there's only one number that will solve this equation because what's the power of x? Is it not the first power? And that means that there is only one answer to the equation. Now I'm going to contrast that with this equation. X squared minus 5x plus 6 equals 0. Now this equation is of degree 2. The highest power is 2. So therefore it's called a quadratic equation because quad means 4. Well, the general formula for a quadratic equation is ax squared plus bx plus c equals 0. So in this particular quadratic equation, can you tell me what a, b, and c are equal to? A is 1, b is
5.
No.
-5.
-5, thank you, and c is 6. Now, this particular equation has 2 answers. Now, you might not have expected that one equation can have 2 answers, and you might not believe me. But those 2 answers are x equals 2 and x equals 3. Now, I know that you believe me up to a point, not a very big point. So the only way you're really gonna think that those are the answers is if we plug them in and check, agreed? So let's go about checking this. What I have is 2 times 2 minus 5 times 2 plus 6, does it equal 0? 4 minus 10 plus 6, does it equal 0? 10 minus 10, does it equal 0? 0 equals 0. This checks. Now let's put in 3 and see if it checks. 3 times 3 minus 5 times 3 plus 6, does it equal 0? 9 minus 15 plus 6, does it equal 0? 15 minus 15, does it equal 0? 0 equals 0. 3 also checks. So one equation clearly can have 2 answers, and it does. Now I knew that it had 2 answers because what was the power of x? 2. That means it has 2 answers. Now, let's look at this equation. How many roots does this equation have? 5. And by answers, we use the word roots. It has 5. Now, in the course that this replace Math 107, we would find those roots. But we won't find them in here. We'll just deal with power 2 equations, quadratic equations. So what we now need to know is how is it that one finds the previous board? How is it that one finds these 2 values when you're given the quadratic equation? You use the principle of 0 products. So please tell me, and think about your answer, don't just really jump into it. 4 times 0 is equal to what? 0. Now a harder one. 0 times 4 is equal to 0. And in fact, if you have 2 factors, a times b, and if you know their product is equal to 0, then that is possible in 2 situations. If a alone equals 0, doesn't matter what b is.
No.
If b alone equals 0, does it matter what a is? No. So I'm going to give you an equation now. Here I have A, and here I have B. So I can apply the principle of 0 products. We have the factor A times the factor B, and we know that their multiplication yields a 0. That's true under 2 situations. What are the 2 situations? When A alone equals 0 or B alone equals 0. So that's true in 2 conditions. If x equals 8, x minus 8 equals 0, or if x plus 3 equals 0. So now let's solve these 2 smaller equations. This is solved x equals 8, and this is solved x equals minus 3. Now let's verify that this does produce truth in our given equation. Let's start here, testing x equals 8. 8 plus 3 is what? 11. But 8 minus 8 is? And 0 times 11 is? So that works. Now let's test minus 3. Minus 3 minus 8 is? But minus 3 plus 3 is? 0. So you see, it does check by the principle of 0 products. So now on your worksheet, can you guys please do number 34? What are the 2 roots? The 2 values of x that solve the equation. X minus 11, x minus 5 equals 0. So using the principle of 0 products, x minus 11 alone equals 0, or x minus 5 alone equals 0. Double check those signs. Yep. Yep, this is the first one's a plus. So, this produces x equals minus 11. This produces x equals 5. And if we put those into the given equation, we find that indeed they both produce 0. So now notice, this is the root, it has a minus sign. And the factor, it has a plus sign, agreed? And that will always come out to be true because when you set it equal to 0, it goes over to the other side. So now everyone please do number 35. 35. Find the two roots. And Como, your two roots are, please.
Wouldn't it still be x is -5 and then x is plus 2?
X is -5. Well, if you put in a -5 for x, it's not quite that easy. It's close. So we have 4x plus 5 and x minus 2. So let's set them individually equal to 0. 4x plus 5 equals 0, x minus 2 equals 0. So this is -5 on each side. 4x equals -5. Divide both sides by 4, and x equals -5 over 4. And this one is x equals 2. So let's try the next one. 13(6). Jordan, your answers, please.
-9 and 1/3.
All in favor? -9 and 1/3 carries. Done. Okay, now I'm going to write two numbers on the board, and you please tell me if they're the same number. Are these the same number? 12 and 4 times 3. Just different ways of representing the same number, true? Now, if I give you an equation, then I know that this has how many roots? 2. And I'm going to use the principle of zero products to find them. Because, can I not factor this? X plus 3 and x plus 5. Boil it out. 3x, 5x, bingo, it works, agreed? Now, just as 12 and 4 plus times 3 are the same, then this and this are the same equation. One is in factored form, the other is in multiplied form, but they are exactly the same equation. Just as 12 and 4 times 3 are the same number. So that means that the roots of this are the roots of that. And we know how to find the roots of these by the principle of zero products. X plus 3 equals 0, and x plus 5 equals 0. So x is equal to a -3, and x is equal to a -5. Which you can verify by substituting into the original equation. So when you have a quadratic given to you, what you do is attempt to factor it and set each factor equal to 0. So I just did 37. So can everybody do 38? X squared plus 5x plus 6 equals 0. So factor it and set each factor to 0. And Jeremiah, your answers are, okay, what's your first step? Did you able to factor it? All right. Chanel, your answers?
-2, -3.
-2, -3, bingo. -2, -3 is where we want to go. Let's go to the next one, 39. X squared minus 2x minus 15 equals 0. first task is to factor it, set each factor to 0. And Emilio, your two answers are,
X equals 5 and X equals
a
negative
little louder for me, please.
3. X equals 5 and X equals negative 3.
X equals 5 and minus 3. Support. Objections. Well, not much vote. Okay, support there too. Objection. The support? Chanel,
Oh,
same?
I don't know yet. I don't know, man. I don't know.
Okay, let's factor this guy.
You do it.
So they're gonna have different signs. So we're gonna have an x minus 5 and an x plus 3. So setting each factor equal to 0. X minus 5 equals 0. X plus 3 equals 0. So x is equal to 5 and x is equal to minus 3. Okay. Let's go to the next one, okay? 40. X squared plus x minus 42 equals 0. So first step is to factor, then set each factor to 0. And Alex, your two answers are, please.
Equals negative 7, x equals 6.
We have winners, x equals minus 7 and 6. Anyone want to see some steps? No steps. Okay, now I'm going to write another type of problem on the board, and it's one that I have no procedure for how to do. X squared minus 4x equals 21. I have a procedure called the principle of zero products, but I have no procedure for the principle of 21 products. So I'm stuck, unless I can generate a 0. Can I generate a 0 on the right-hand side? By doing what? Minusing the 21 on both sides, x squared minus 4x minus 21 equals 0. Now I can use the principle of zero products. Not until. You have to generate the 0. So now you can proceed. Chanel, again, your answer?
Negative 3 and 7.
Negative 3 and 7. Support? Objections? It carries. Okay, so can everyone please do number 46? X squared minus 14x equals minus 49. answer is, show, come on, answer.
It doesn't.
It does. Somebody got seven. There's seven. No, you said, I thought you said it had two roots, it does. Both of them are seven though, it's called a multiplicity of two. The roots are 7 and 7. That's a fine algebraic point that we won't pursue in this course. It has to have two roots, so it's second order equation, but both of them are the same. 7. Okay, now we're gonna write another one on the board, x, 6x plus 13 plus 6. Any thoughts as to how we might start on this equation? Distribute the x, see what we get. 6x squared plus 13x plus 6. Now we can use our usual tools, agreed? This one might not be so easy to factor with those 6's on both ends. So, have a go. Jordan, your answer please.
-1.
Any other answers? Dylan?
I haven't finished yet.
No, check, double check. Unless I copied it wrong, I did not copy it wrong. So, check, error someplace, blunder. Too many combis. Chanel, again.
Oh, I don't have it.
Ooh. Running dry. Emilio.
X equals -2 over 3 and x equals -3 over 2.
We have winners. Anyone want to see Emilio show? Yes, a lot of people.
Oh, okay.
This is a tough one to factor.
I'll move this up. I'm kind of hot at it, so
Pardon me, sir?
I'll move this up.
Sure, down here.
So, we start off with this. And I use 3 times 2 and 3 times 2 for this one. So it should be 3x. times 3. So 3 times 3 is 9. And then this is going to be 2x and 2.
This is a highly individualized procedure that works for me.
3 times 3 is 9 and 2 times 2 is 4. So 9 plus 4 is going to equal 13x. And just have them both positive.
Equals 0.
Equals 0. And then, so we got 3x plus 2 equals 0. And 2x plus 3 equals 0. So then I got 2x equals 3. And negative 3 over 2.
So, very well done, right? There it is. Okay, so now let's do an entirely different type of problem. Let's go in your textbook, page 162, number 84. The sum of two numbers is 15. The product of the two numbers is 36. Find the two numbers. Now, you can do this by trial and error and not get any points on the test, because the instructions will be solved by using an appropriate equation, as you see. So we want to have this done systematically. And Alex, your two numbers are? Oh, okay. Now, people will say, well, trial and error is just as good, why can't I use trial and error? Okay, then we just change the problem a little bit. The sum of two numbers is 3,492, the product of the two numbers is 16,712. And trial and error all you want. So we do need the systematic approach. Oh,
Wait, you say gotta do it?
feed me. Okay, let's start. The sum of two numbers is 15. What are you going to call the two numbers?
X and 15 minus.
X and 15 minus x. So x equals first number, and 15 minus x equals second. Now just read the words. What words come next? The product of the two numbers is, so can you multiply those two numbers? Can you multiply x times 15 minus x? X times 15 minus x, and set it equal to, so the product of the two numbers, x times 15 minus x, is equal to 36. So, now this will be your first quadratic with a minus x squared, so another new challenge. So Como, you, no, it's still working, everybody's still working. Now, in all fairness, you didn't get a chance to read the example in the text, so this is a jump. So let's multiply this out. 15x minus x squared is equal to 36. But I need the principal of zero products. So I do a minus 36 on each side. And I get a 15x minus x squared minus 36 equals 0. And I'm just going to rearrange it so it looks more normal. Minus x squared plus 15x minus 36 equals 0. Now you can go one of two directions. You can either factor it directly, or you can do what I prefer to do, because I don't like to factor minus signs, is I'm going to multiply both sides of the equation by a minus 1, which I can do. And if I multiply this side by minus 1, I get a plus x squared minus 15x plus 36. And if I multiply a 0 by a minus 1, I still get a 0. So this is a cute little trick that you can make it look more friendly. And when I factor this, I get an x minus 12 and an x minus 3 equals 0. So x minus 12 equals 0, x minus 3 equals 0, and x equals 12, and x equals 3. Those are my two answers. If you don't like to do that trick, you can just factor it directly. So you're going to have a minus x and a plus x. Now, you have to maneuver to get a plus 15 in the middle. Means everything has to generate, so 36 is 12 and 3. 12 and 3 add up to 15. So you need to get the 12 and the 3 to add up to a plus 15. So you have a minus 12 here and a plus 3 here. Let's check it by foiling. Minus x squared plus 12x plus 3x minus 36 minus x squared plus 15x minus 36 is the equation. So we have FOILed it. And now we set each factor equal to 0. And the factors are minus x plus 3 equals 0, and x minus 12 equals 0. So let's subtract a 3 from each side. Minus x equals minus 3. Now let's multiply both sides by minus 1. We get x equals plus 3. This is x equals 12. So whether you attack the equation directly or whether you multiply both sides by minus 1, you find your two answers, 12 and 3. Good. Okay, so in the presentation, you guys get to finish this off with some whiteboard work. So first we're going to do 3.4. Each person will get a large number of problems. So please write down the ones you get, because there are a lot of them. Wave me off if you don't have one. 2, 3, 6, 8, 10, 13, 16, 19, 21, 23, 25, 28, 33, 36, 37, 39, and 45. Okay, let's go there on.
3 plus 1. 10 over 3, 10 divided by 3 is 3.3 repeating. And move your decimal point